Hello, viewers. So in this example, we'll be looking at composing trigonometry, still under composition of trigonometric functions, inverse trigonometric function, and trigonometric function. Now, here, how do we solve this type of problem? If you look at this, you see that the numbers there, they are not one of those famous angles. Because if you have, for example, sine inverse of -1, these are famous, sine inverse of √3/2, but this is sine inverse of -5/6. So what we can do is we can let what is inside, for example, y, be equals to what? Sine inverse of -5/6, right? Now, the moment we do that, it means that our problem now becomes what? Cosine of what? Of y, right? So it means we are looking for cosine of y, right? So here we have y is this, and we know that sine inverse can only be in the first or in the fourth quadrant. And if you take sine of both sides, we will have that sine y is equals to -5/6. So it means that sine is negative, which only happens in the third or in the what? In the fourth quadrant. Right now we have to pick our common quadrant, which is quadrant number 4. Okay. Now, unlike in the previous video we did in this series, this section, you will see that we cannot get y star. You remember what is y star? Y star is an angle in the first quadrant, which the sine should be 5/6. But you see, 5/6 is not famous. It's not, you cannot get any famous angle whose sine will be 5/6. So how do we handle this case? So what we need to do is we need to go to we need to have a diagram, just draw something like this. But don't forget that we are in the fourth quadrant. So this will be the fourth quadrant. And let's call this one y. And use this information. So this is going to be 5. And this is going to be 6, right? But the 5 is going to be negative. And then with Pythagoras theorem, we can find the other side, right? And what will be this side by Pythagoras theorem? This will be root of what? Root of 36 minus 25. So this is going to be, I think, root of 11, yes? So root of 11. Yes. So we're almost done. Now, if we look at this, remember our problem has reduced or has changed to what? To looking for cosine of y. After we did this substitution, remember the problem became cosine y because this is cosine, yes? So cosine, the whole of this is what? Is y. So all you need to do is just come to the what? Come to this diagram and look for cosine. What is cosine? Remember, cosine is just x over r, right? Which is adjacent over what? Over the hypotenuse. So this is just root of 6. I mean, root of what? 11/6. And we're done. All right, and we know that we're in the fourth quadrant, so cosine should be positive. So similarly, here, we do the same thing. We just say y, you can let y be equals to cosine inverse of 2 over 5. And that means that what? Our problem now becomes that we are looking for sine of y. Yes. So because the whole of this is y. Now, cosine inverse is either in the first or in the second quadrant. If you take cosine, this is simply because of the range of cosine inverse. Yes, so cosine y is going to be 2 over 5, which means that cosine is positive. So this can only happen in the first or in the fourth quadrant. Then now we go for the common quadrant, which is quadrant number 1. All right. Also here, we cannot get y star, because if you want to get y star, it's going to be the famous angle in any angle in the first quadrant whose cosine is 2 over 5. But we cannot have that. So what we do in this case is that we go and sketch. We will be in the first quadrant. So this is the first quadrant, and this is going to be y. So cosine y is what? How do you find cosine? It's adjacent. So this means this is going to be 2. And hypotenuse, this is 5. So by Pythagoras theorem, we can find the other side. What will the other side be? This will be the square root of 25 minus 4. So this would be square root of 21. Right. Now, we're almost done. So what is sine y? Sine y is going to be what? Is you just come here and look for sine y. Sine is opposite over hypotenuse. So this is just going to be root of 21 over what? Over 5. All right, so let's look at these ones. Number C, tan inverse of tan minus pi over 3 plus this. If you look at this one, you will see that what do we need to do? We have two terms. We have this and this one. So let's take this first term here. Let's take this, deal with this one. Tan inverse of what? Tan minus pi over 3. This one, the answer is simply what? It's simply minus pi over 3, right? And this is because of what? This is just minus pi over 3. Since minus pi over 3 is what? Is in the interval minus pi over 2 minus pi over 3, right? Okay. Now we're done with that. So it means we just need to deal with this second part. All right. So let's take this one here. Now let's deal with the second one. The second part is tan. So I'm dealing with this one now. Tan of what? Sine inverse of root 2 over 2. Okay. So this we will just follow the same procedure. We will let's let what's y to be sine inverse of root 2 over 2. Okay, I think this is even a good one. We can do this one easily, actually. but it's okay. So it means that what is sine inverse of root 2 over root 2? So it's just going to be 45, right? So here we don't have to, sine inverse of root 2 over root 2 is just pi over what? It's just pi over 4, right? So since this is a standard angle, it's fine. This is the same thing as tan of what? Of pi over 4. And what is tan pi over 4? It's just what? It's just 1, which is tan 45. So it means that this is what will be the answer? The answer for this is just going to be minus pi over 3 plus what? Plus 1. Yes. Okay. Now, just to add something extra here, in case you are wondering, one way to solve this again, this one we went directly sine inverse of root 2 over 2, right? This is it. But if you want to make it longer, or you want to add more, how do you do this? You can let y be what? Be sine inverse root 2 over 2, right? Oh, once we do that, all right. So here it means that we are looking for tan of y, right? So similar to what we just did now. So here, this is sine inverse. Sine inverse can be in the first or in the fourth quadrant. And it means that sine y is what? Is root 2 over 2, which is in the which quadrant? Sine is positive in the first or in the second quadrant, right? So which quadrant is common? Is the first quadrant. So it means we're in the first quadrant. So now if you look at this one, in this case, we even have more than one way to solve this now at this stage. Yes. We can find white star actually, if we like, or we can just go and draw the diagram. Here it's easy to find y star because root 2 over 2 it will give rise to a famous angle, right? Okay. To give rise to a famous angles. Or we can still go and just draw the diagram if we want. We know we are in the first quadrant. So the first quadrant, this is it. So this is going to be y root 2 over what? Over 2, opposite over hypotenuse. This is sine. And then we can find what is the adjacent, because the adjacent will be required, right? So what is the adjacent? Now we use the Pythagoras theorem. Let's see. Okay. Now you see that the Pythagoras theorem, what will be here? This will be the square roots of what? 2 square, which is 4, minus the square of what? The square of root 2, which is 2, right? So this is also going to be the square root of 2. So this is the square root of 2, which is the adjacent, right? Now, remember here, we said this problem has been transformed to where? To tan y. Okay. Now, what is tan y from here? You can see that tan y is going to be adjacent over what? No, sorry, opposite over adjacent, which is root 2 over what? Root 2, which is just what? 1. So this is another way to explain this part, the second part of this problem. All right, so the answer, final answer is minus pi over 3 plus 1. All right, so this is how to compose trigonometric functions. And thank you for watching. If you have any comments, just write it in the comment section.